Many of us think of Alan Turing as being the famous codebreaker, the great mathematician, or perhaps the father of modern computing. What's less well known is shortly before his death, Alan Turing shifted his focus towards biology. He published one of his most influential and important works, his theory of morphogenesis, or how nature gets its pattern and form. Turing imagined that developing animals have two chemicals inside them, and the way that these chemicals react and move around the body can be explained with mathematics. Turing's ideas explain many of the patterns we see in nature, such as a zebra's stripes and the way our hair grows in a spotted pattern, and we often call these patterns Turing patterns. Like many of his achievements, it wasn't until decades after his death that Turing's work in biology began to be recognised, and now it's used by scientists all over the world. Turing's work doesn't just explain patterns in nature, it also helps us understand many important biological processes, such as how cancerous tumours grow, how our immune system responds, and also how epidemics spread. And this is still relevant in research today. At the university, PhD researchers are using Turing's theory of patterns to understand a really important part of brain development.
So my PhD research involves investigating how the development of an important region of the brain called the hypothalamus works. Turing's ideas have had a tremendous impact on the field of developmental biology. Turing himself acknowledged when he outlined his theory that the reality was probably much more complicated, and he was actually proven right in subsequent years with advances in molecular biology and genetics that showed us really just how astonishingly complicated the development of the embryo is. However, Turing's ideas are still really relevant to developmental biologists today because we have these huge data sets that are incredibly complicated, but to really interpret those and gain some meaning out of them, we can use Turing's ideas as a framework with which to base all of that on.
This year, Alan Turing's legacy is being celebrated as he appears on the new British £50 note. The university has teamed up with the Bank of England to introduce the mathematics of Turing patterns to schools all over the UK.
Here at the Bank of England, we want to get young people excited about maths and science and show them how these subjects relate to the natural world. And it's for this reason that we're so delighted to have teamed up with the University of Sheffield on this project.
The Turing Pattern Project provides engaging lessons for teachers to learn about Turing patterns with their students. As well as learning about patterns in nature, computer algorithms and Turing's life, students are given the chance to collaborate with other students in the UK to form the pattern of the giant pufferfish. Local schools in Sheffield have already been trialling the lessons.
Hi, my name's Joe Cooper. I am a maths teacher at Birkdale Prep School in Sheffield, and the Year 5 set that took part in the project absolutely loved it. They loved the realism, they loved the fact that Alan Turing's a real person and they could learn more about him. The fact that it linked to animals and biology ticked a big box for a lot of the children. They loved learning about different patterns on different animals, zebras, giraffes, everything. It's a fantastic initiative and I would thoroughly recommend it to any other class teachers out there from Key Stage 2, as it ticks so many boxes in a maths classroom and the children will really enjoy it.